stands as a high velocity. Angular acceleration is greater than the 2000 degrees per second square. And the result is observation and recording of high head synchronism. This is the displaying of the result. We can see the canalogram. We can see a plot of the velocity of head high and time in second, and here a graph of the line of gaze, and the time is a numerical and morphological analysis. How does the remote camera VHIT calculate the position of the eye in the orbit? It's a very important question. Please notice here, if the eye rotating and steady head, there is a reflection of the shift. The reflection of infrared source is moving on the cornea. But if we have a steady eye and a steady head, the reflection will be steady too. Last, and the most important, if I have a steady gaze and a head rotating, the result will be a steady reflection, because corneal reflection remains stable if the eye turns opposite to the head of the same amount. So, as we have seen, the corneal reflection of an infrared source placed in front of the patient is used as a reference to measure the direction of the gaze. In a normal patient with a head rotation, we will get a steady gaze. It means a steady reflex and a steady pupil. Please notice the video. The head is moving, but the reflex is steady and the pupil so. The eye moves in the opposite direction to that of the head during movement, so that the line of gaze, this one, has a constant value. But if our VOR is deficient, with head rotation, we will get an unsteady gaze. That it means a steady reflex, but a shifting pupil. The line of the gaze is quite different. Please see the video. Voila. And see again it. It was very interesting and important to understand. The eye remains in its initial position in the orbit at the beginning of the movement, and later we will see a covert saccade and overt saccade that brings back the line of gaze to the right position on the target. Main advantage and unique features of the remote camera VHIT. The main advantage are absence of device placed on the patient face, as said Emanuele, and in this time it means no device to sanitize between a patient and another, and the second one. Simultaneous biocular record for the lateral semicircular canals. The eye right, left, or both, to be analyzed can be chosen. There is an automatic detection of eye position and stimulation plan. A minimum of 5 impulses are sufficient for each canal. Shorter examination and more comfortable examination for the patient. But the size of the face in that syndrome is no longer a problem. Thank you to Sylvette Wiener-Vacher, Paris, for doing her very important paper about the analysis of VHIT remote camera in children. Which are the unique features? We have just seen the so-called graph of the orientation of the line of gaze. So there is an evaluation not only of the velocity graph, the most common, but also of the line of gaze. Why? The line of gaze is very important because it tells us if the gaze can stay or return on the target. The velocity graph does not provide us this info. Second, very important, the possibility to review the video of each impulsive movement, so we can get a precise evaluation of the eye movement in a slow motion in order to identify artifacts or true eye movements. And then, last but not least, a graphical and numerical analysis of the covered saccades. It gets the calculation of the apparent gain after the saccadic movement. So, if the VOR gives us a 0.64 for an impulse movement, with the addition of the covered saccade, the gain rises to 0.98, and this represents the true position of the eye at the end of the movement. So, some very important concepts about morphochronological analysis of VHIT graph. The video input test, we know, is a selective analysis of each of the 6 semicircular canals. But we cannot forget the pursuit and its contribute to the final eye position, because many paper of physiology of this ocular reflex tell us that the pursuit can rise up to 100 degrees per second or 120 degrees per second, and the last one 100 degrees per second, the upper limit of a human smooth pursuit velocity. In this way, we cannot forget that the video head impulse test must be performed at high velocity. And we have just seen their value. A fundamental concept for the correct execution of the VHIT is the high velocity. Please look at this sample. This is a right lateral semicircular canals. If the head impulse is performed at 130 degrees, the gain is 1. So it appears all okay. But if in the same patient for the same semicircular canal, we perform an impulse, a head impulse with 250 degrees per second, the gain decreases to 0.68, and this is a pathological value. What this patient had a right intracanal neurinoma. With the VHT, we have the possibility to build up a velocity gain plot. Here, in a normal subject, you can see that for velocity greater than 200 degrees per second, the gain remains about 1. But it's very different, the behavior of a pathological subject. In the pathological subject, at the lower velocity, the gain could have a great value, but it decreases very quickly, in a rapid way, to the high velocity. Some ideas about this concept. I perform at a very low velocity an head impulse. The gain is 1. Okay. I can have a lot of impulses, all about the gain 1. So this is a typical set of stimuli performed in a very small velocity range. It will certainly have a very low value of sigma, but is such a test reliable? Can it give us all the information it could? Some example. The same if perform the test at higher velocity, I can get the gain about 1 also in the higher velocity, but the gain could be of this kind. It could decrease with the increasing of the velocity. If I start with a low gain, I will see a decrease of the gain with velocities increase. And if I find a very, very slow gain at low velocity, at high velocity, there is no gain. Because when the gain is very low at a low velocity, never will increase at the higher velocity. So this kind of graph does not exist. These are the reason why we need to perform high velocity head impulses. Some reflection about the VHT. I explain my principia. First, as VNG is above all a technique, the VHT is mainly an art. It expresses itself with the examiner ability to perform impulsive movement of the head at high velocity. Very important, high velocity. We must learn to move the head of the patient at high velocity. Second, the correct execution of the VHT requires a patient who keep his eyes open, have a manageable neck, has the intention to observe the target. Third, the video